This video explains how to move the AGV to multiple coordinate positions and coordinates of other components. Add multiple coordinate positions to the AGV's path by the following steps. Open the Python script editor window of the AGV, change the variable name from point to point 1, and create a new vector whose variable name is point 2. Set 2000 to x and y and 0 to z. Write a for statement as follows. For p in point 1, point 2 colon. Then, start a new line. Write vehicle.add control point, p, so that the AGV moves to point 1 and then to point 2. After that, the AGV stops. Compile the Python script and perform the simulation. The operation is performed according to the setting you have configured. The following explains how to move the AGV to coordinates of other components. Set the instruction to move the AGV to the robot position. Reset the simulation and select the Home tab. Select the robot and move it. Open the Python script editor window of the AGV and comment out the point 1, point 2, and for statement lines. Write app equals get application parentheses. To specify the robot component, write robot equals up.find component parentheses. Write the component name in parentheses. Write the robot name displayed in the component properties window of the robot. To obtain the robot's world position coordinates in the 3D world, write WPM equals robot.world position matrix. The position vector of the VC matrix object can be accessed by obtaining the P attribute. Create a new variable robot_point and write WPM.P so that the P attribute of the robot's world position coordinates can be obtained. To move the AGV to the robot position, write vehicle.add control point, robot_point. Compile the Python script and check the operation. Perform the simulation. The AGV moves to the robot position. The following explains a method other than obtaining the robot's position coordinates. Comment out the lines that obtain the robot's position coordinates and create a new variable p1 to obtain the current position of the AGV. Write comp.positionmatrix.p so that the position vector of the AGV can be manipulated. Create a variable p2 and write robot.positionmatrix.p. Assign the robot position to the AGV. To move the AGV from P1 to P2, write P2-P1. The vector from the AGV to the robot can be obtained. Compile the Python script and perform the simulation. The AGV moves to the robot position. The following explains how to refer to the coordinate position vector. Reset the simulation. Create a frame to the robot to specify the position to which the AGV moves as follows. The origin of the component is used. Note that frames can also be used. Select the robot and then the Modeling tab. Select the root node in the Component Graph window, click Features in the Geometry group, and select Frame. Move the frame in the x-axis direction and away from the robot. Change the frame name to Pickup Location in the Feature Properties window. Move the AGV to the frame position by the following steps. Return to the Python script editor window of the AGV. Use the vectors of the AGV and robot. To obtain the frame added to the robot, create a variable frame. Write robot.getFeature to obtain the feature in the robot component. Write pickup location in parentheses. Write npm equal from.node position matrix to obtain the position of the frame relative to the node. The coordinate position vector can also be obtained. Write frame_point equal npm.p. Set the move instruction for the AGV. Delete P1 and P2. To move the AGV to the frame position, write frame_point. Compile the Python script and check the operation. Perform the simulation. The AGV does not operate properly because the robot's position coordinates are obtained. When assigning the vector, the AGV was supposed to refer to the relative position of the robot, not the current position. Correct the description as follows. Use the robot's world position coordinates to obtain the world position coordinates of the frame. There are the frame and the robot component. Write WPM equals robot.world position matrix to obtain the robot's world position coordinates. Since the variable NPM obtains the node position coordinates of the frame, write frame_point equal WPM*NPM.p. Multiply the node position coordinates of the frame by the robot's world position coordinates so that the world position coordinates of the frame can be obtained. Compile the Python script and perform the simulation. The AGV moves to the frame position. This is the end of how to move the AGV to multiple coordinate positions and coordinates of other components. Thank you for watching.